All right, guys. Good afternoon from Ghana. Welcome to another session of the electronics tutorial series. In this session, we are going to look at how to etch a PCB using toner transfer method. If you have been following since the previous off-class sessions, in the last session we designed the PCB. So the next thing to do is to fabricate it and assemble the components. Okay. All right. So before we can do that, there are two things that we have to do. If you are producing the board for a fab house manufacturing, then you have to generate what we call the Java files. Okay. So in this particular next session, I'm going to show you how to do that and then take you through the process of etching a PCB board. Okay, right. So let's get started. So this is our work done so far. We have successfully routed the board, and if we check the 3D view, you realize that everything has been laid out neatly. Okay. All right. So in case you weren't following, please get the previous video and catch up. Okay, so this is the board that we are going to develop. A very simple board, two-sided PCB. So before we can actually proceed, two things. If you are developing for, let's say, JLC PCB, then you have to plot your Gerber files. Okay, by going through this process. Now, because that's not what I intend to do, I won't go through that. I won't go through that process now. But for what we are about to do, we have to print the PCB. Now, since we are dealing with a two-layer PCB, we have to print both the front and the bottom sections. Okay. So to do that, we go to the print menu and then select the FCU. The FCU stands for the front copper. Okay. Now the technical layers, we are only interested in the edge cuts and the front copper itself. So we have already selected the front copper. The next thing to do is to select the edge cut. Okay, that's all. You don't need any of the layers again, unless probably you have the capability of printing, let's say, the silk screen or any other of the technical layers. Then you just need the edge cut. Okay. Now this is the front copper. Always you have to print it mirrored. Okay, the front copper should always be mirrored, else when you print it out, you're not going to get the right thing. We want to print it in a black and white color, and the scale, you have to make sure that there is no scaling, so you choose 1:1. The moment your board scales, it means that something will go wrong with the footprint. Okay, so make sure and always and uncheck this print border titles. You don't actually need them. Okay, before you print out, check your page setup and make sure the printer, the sheet size that you want is what you are actually using. Okay, so here, as you can see, we have A4 selected. It's in the landscape mode. That is okay. Now, if we go to print preview, and I will encourage you to do that, so since sometimes you may not get your settings right. Okay, so this is supposed to be the front cover. I think everything is okay. And then let's check our printer. Oh, okay. Right now, I don't even have a printer connected, so we're going to configure Microsoft Print to PDF to do that job. So I'll select it and go to Preferences. One important thing is to make sure that you are dealing with the right paper size. In our case, we are using A4 sheets. So we select the A4 sheet, and that would be all. Okay, so you print just 2 copies for the front pages, and that will be it. So this is going to generate a PDF file which you should save to any location of your choice. I'm going to save it to my desktop. Okay, so I'll call this front page. and then save it as a PDF document. Okay, right. Now the next thing to do is to generate the design for the bottom section. So make sure you have unchecked the front CU, and then selected the BCU, which is the back copper. Then again, we only need the edge cut, no more. Only need the edge cut. Now for the bottom, you make sure you have unchecked the print mirrored. You don't need to mirror the bottom. It automatically comes out correct, okay? And make sure you have selected black and white. The scale is on 1:1. And then you check your paper settings again. This is very important because if you don't do that, your work may end up scaling. So this is the bottom section of our design. Once again, we make sure that the printer settings are intact and not changed. All right, the paper size is A4, so that is good. Now we can print it out. So once again, I'll save this as the back page, and we can now print out our work. Now, if you don't have a printer connected, or if you're not printing the thing by yourself, then you have to make sure that whoever is doing the printing does not make the work scale up. Okay, it is easy to get your work scale up if the person printing does not do the right thing. Okay, so I'm going to show you some of the things that you can do when you are doing your printing. First of all, for this work, we need a photo paper. Okay, so this is a photo paper. It's a card-like paper. Now, when you go to the market to get a photo paper, there are different grammages. Okay, so this one is about 130, about 130 grams. Okay, make sure you get the lighter ones. If you get a heavy or a thicker one, it may not etch well. Okay, so something like 200 grams and those things, don't get it. Okay, so I'm going to use a photo paper. Now the advantage of using a photo paper is that you don't have to wash your board after the printing, after transferring the design, but you can still use an A4 sheet for this anyway, a normal A4 sheet. But with that, after transferring, ironing the design onto your copper board, you would have to etch it, put it in water to wash off the paper. Okay, sometimes you end up breaking some of your traces. So with a photo paper, the moment that the wet cools, your ironing cools down, you can actually peel it dry, and it actually comes out very nicely. So that's what we'll be using for this work. Okay. So take note, when you are printing, make sure actual size has been selected on the printer, the right paper size. If it is A4, A4, it is a letter. Check all these settings, okay? And you also want to put your printer on a very deep printing mode, okay? Something that will make the color come out very nicely. Now, be careful of the toner. There are some refills available out there with very high temperature, and sometimes it is very difficult to get your ions to melt them completely, so you end up with distorted designs. Okay, so these are some of the things that you would encounter in this particular thing, but with experience, you would know how to get the things done right. All right, so I'll pause here. We're going to print out the paper, the design, and then we'll continue from there. Okay, so that is the printout. This is for the top copper. Okay, this is for the top copper. Let me set up. Okay, so this is the top copper, the design for the top. Okay, if you look at it carefully, you realize that it is actually inverted or mirrored. Okay, and this is for the bottom copper. Okay, now one thing that you should always make sure you do is to use a laserjet printer, not an inkjet or any other thing. Okay, you need the laser jet, because the method that we are going to use, we would end up heating this, ironing the back of this sheet. Okay, so this toner here, which is a carbon compound, would melt and get attached to the surface of the copper. Is that okay? So the part of the copper that gets covered up would represent our design. So you can't do this with an inkjet printer. It has to be a laser jet printer. Okay. So the next thing that we're going to do is to prepare the board and then ready it for transfer. Okay. Now, this is the board that we are going to use. Like I showed in the previous video, it's a double-sided copper board. Okay. However, you can see that it is very dirty. The board is very, very, very dirty. So the first thing you do is to clean the board and make sure that it has no dirt or even fingerprints on it. Okay, so that's the first thing that we're going to do to this board. And then before we do that, we'll cut exactly the size that we need and then clean that part. Okay. All right, so carefully cut out your design. I prefer using this two scissors. Okay, so this is okay. Okay, you can see that I trimmed it at exactly the edge cut, the outline of the board. Okay, but this is okay to leave. It's okay to leave this side there. So we do the same thing to the top cover. Okay, so this is also ready. Okay, now what I usually do is to put it on the board and then mark it out. Okay. Now, using any hacksaw cutting tool, I prefer this one. All right, so this is the piece that I'm going to create the board on. As you can see, it's very dirty. Okay. Now, looking at the nature of the dirt on this board, you could decide to use a mesh, a wire gauze, or something to clean it, right? But that would end up taking a lot of the copper away. So what I'm going to do right now is to first use thinner to clean the dirt, then I will use the wire gauze to wipe it clean. But then the best solution for cleaning copper is acetone, but it's very expensive. So thinner can do the job very well. Acetone is preferred to thinner. Okay, so we managed to clean. Okay, so right now managed to clean the board, especially the dirt that was on the board. Okay, but it is not completely cleaned. Okay, so the next thing I'm going to do is to wipe it clean with just a wire gauze, a very fine mesh, the fine mesh type. Locally, we call it silver shine, right? This type of wire gauze. Don't use the very coarse one. You need the fine mesh. Now, this last shining or cleaning that I'm going to do, you have to ensure that you don't leave your fingerprints on the copper. Okay, so ideally, when you are doing these things, you should put on gloves. But then, where I am at the moment, I don't have gloves with me. So what I'm going to do is this. I'm going to wrap this in a sheet of paper like that and make sure my hands doesn't touch the moment I clean that particular place. Okay, so usually it is a good idea to do it in a particular direction. Okay, make sure you don't leave fingerprints on it. And take note that the copper on the board is just a film. It's a very tiny film. Okay, so do you don't wipe it so much, else you reduce the thickness of the copper. So you take your time and clean it nicely. Okay, at this point you should ensure that you don't leave any fingerprints on it. Okay. Okay, so now turn it and then do the same thing. Mm. Do the same thing to the back side. Put the iron on. And papa. Okay, so now we've cleaned every grease on the surface of the copper. Okay, it is ready to be used. At this point, like I said, you make sure you don't have your fingers don't touch it. So ideally, you should be wearing gloves. Okay, wear gloves at this point. So you can see that the copper is shining now compared to how it was initially. Okay, all right. So now what we're going to do is to nicely and precisely align the front and the back designs on the copper and hold them down with masking tape, paper tape to be specific, okay? So that they don't move. You have to make sure you secure it tightly so that it does not move. Let me the paper tape and the scissors. Okay. Now, this is the tricky part. For double-sided board, the moment you misalign the top and bottom, you are going to have issues, okay? So it takes some amount of carefulness to pull out a double-sided PCB. If it were to be a single-sided PCB, I mean, it is simple. You can just put it there, iron it out, and go your way, right? But then now we have to make sure the holes are aligning and all that. So it takes some amount of carefulness to pull that. Okay, so that's what we're going to try to do right now. Okay, so this is the bottom design. Watch carefully. Okay, so I'm using this side as a reference. Put it here, and it doesn't matter which one goes where because the design is already mirrored. Everything should play out fine. Now, actually this is the bottom, the first one. This one is the top one. Okay, so you see this side actually goes here, and if I orient this right, okay, you see that the place I'm using as my anchor goes to the same place. Okay, now usually you want to grind a part of your board to make sure that the square is perfect. Okay, the corner, it has a very perfect corner. Unfortunately, I don't have most of my tools here, so I'm going to, you know, do some gentleman guesswork. Okay, so it's difficult locating a perfect corner because if you don't get that right, your designs would not properly align and you would have issues with your board. Ideally, you should have two sides that are perfect. Okay, unfortunately, this copper board, uh, no grinder here. That's going to be so sad. And then let's see how accurate I can still uh, pull this up. You see, so I'm just trying to find a place to use as my anchor. Bring the camera a bit down. Yeah, zoom and down. Anchor. Okay. All right. So I think I have one corner that is good. So I will try my possible best to use this. This is seriously not going to be easy. Okay. All right. Let's use this side. Let's use this side. Let's use this side. You have slight misalignment or whatever they call it, but it should work. Okay. So now what I'm going to do is hold these pieces together using this paper masking tape. Okay, right. Now, mostly you could leave some allowance for the tape because usually what I've realized is where you put the tape usually doesn't iron well if you don't put so much pressure. Okay, so maybe when you are trying this out, you would want to leave out some allowance for the masking tape. Okay, well, I think this should play out nicely. Okay, so tape should cover it's a good place because when we are ironing, we don't want the design to move. Okay, now something you should know, if you own the printer you use for printing, that's actually good because then you can look at the cartridge and know the temperature of the toner. Okay, so for instance, if the temperature of the toner you use for printing is like 150 degrees, then it means that you can use an electric iron that can heat up to about 180. Okay, it gives you that kind of preciseness. Okay, but sometimes there have been instances where you can iron the thing and then it will fail. Okay, it doesn't get ironed well. So knowing the temperature, the melting point of the toner, that's what I mean. Knowing the melting point of the toner is very, very important. But unfortunately, I printed this outside and I don't know whether even the toner is original or not, right? So I'm going to try my luck. Trust me, sometimes you can do this thing multiple times before you get it right. It's not usually a one shot thing. Okay, it takes some amount of experience to get used to it. Okay, so you can see that everything is properly secured. Okay, so at this point you should be heating your pressing iron. Now the two things that you should do when you are ironing is it takes the temperature and pressure. Okay, you don't just put the iron on it. No, you have to apply some steady pressure on it as you iron. Now, for double-sided, it becomes a little bit challenging because if you don't do it well, one side will be okay, the other side will just mess up, or if you heat it too much to the heat will end up corrupting the other side. So like I said, it takes a little bit of getting used to in order to pull this out successfully. So let's go and try our luck. Okay, so this is the iron I'm going to use, just a normal pressing iron. Okay, but it should be a good one, something that can give you a good temperature. Looking here, this one is rated, I don't know if you can see it well, 1300 watts, right? So I think it should be able to pull it. Okay, now take note, iron can bend, so make sure you have your protective stuffs on. Okay, so let's start now. When you start, that is the most important thing. You make sure the moment you touch this, the toner will start melting. Okay, You make sure nothing shifts, everything is properly secured. Okay, so look at it. Now I'm not just ironing, I'm applying so much pressure on the board. And the thing is, I can't actually tell whether this will work or not. So funny. Do it gently. And one thing is, as you start ironing, the copper ball starts expanding. Okay, so like I said, you can't get it accurately done with this method. However, you can still get something useful out of it. Okay, at this point, you should turn and iron the other side. The edges, it is very difficult getting the edges done well. Okay, so one way you could avoid it is to give a lot of allowance around the edge, and that means you'll be wasting your copper board. Okay, now if you want to do something as tight as I've done, that means that you have to make sure you give attention to the edges. Okay, because it's one of the places that you are likely to ignore. All right, so 10 again, very hot, so you have to be very careful. At this point, the paper should get stuck to the board. And one thing, you can you can't really know when it is ready. Even after many years of doing this, usually I can't tell when it is ready. So yeah, welcome to this world. Ideally, this thing needs to be secured. Okay, you can see that it is shifting as I'm ironing. It's not a good thing. However, I'm restricted. I'm not in my lab, so oops. Where's the linkage? Okay, pressure and heat. That's the magic. Okay, take note. This thing is hot. Hmm. Well, maybe it is done, maybe not. So let me just give it one more pass, and then we allow it to cool. All right, I think at this point it's okay. So turn off the iron and allow your board to cool. Okay, yeah. Okay, so like I said, the process is not straightforward. Up to now, myself, I can't really tell. So as this board lies here, I can't tell whether it's going to be good or not. So if we take off the sheet and we don't get it perfectly done, we just have to do it again and again and again till we get it right. The unfortunate thing is that sometimes you end up destroying your copper and it cannot really hold the toner, right? So let us just pray that everything is going to work. Okay. Yeah. All right, so the board has cooled enough. It's quite warm at this point. Okay, so like I explained at the beginning, I said that for the photo paper, you're able to peel it dry. Okay, if you use A4 sheets, it will work all right. But after at this stage, you have to put it in water for it to soak the paper. Then you take your time to peel. I mean, that is not so interesting, right? So that's why I prefer the photo paper, except that the photo paper is quite expensive compared to the A4 sheet, but it is worth the cost. All right, so this is the defining moment, whether your board was done perfectly or not, right? Now, chances are that you may have some breaks somewhere. Those are things you can easily fix. However, if it happens that work, a lot of places didn't get transferred, a lot of many parts didn't get transferred, then you are going to have issues, right? That means you will have to redo it, and trust me, it is not a convenient thing to do. Okay, it's not something interesting to do. So let's see how it goes. So try and find out and then start peeling. Now you have to peel gently. Okay, so peeling, have to peel it gently because sometimes if you don't take care, you put too much force on it, you end up peeling hard. That is so bad. Now let me show you something. Look at the sheets, right? You see that there are still some dark spots. Now all these parts weren't transferred perfectly. Okay. So that's bad news. Well, let's look at the other side. If you are fortunate and the other side is good, then well, you could. Okay, so this is the other side. You can see that there are still dark spots. Okay, yeah, but like I said, with the photo paper, you can peel it dry. You don't have to do any washing. Looking at how much patches I have on this and the other sheets, I think I could work with it. Yeah. You could. One thing you could do is try to fix things with something like a permanent marker, okay, or even a normal marker. So let's see if we can do something with that. So this is the board. This is the board that you created. Okay. A lot of things go into the success of this board. The quality of your toner, your heating, the pressure that you applied, all these things, okay, affects the quality of your board. But looking at this, I'll say that well, it is not really bad, not as much as I would love it to be, but we can still work with this instead of trying to create a new one. Yes. So there are a few things that I can fix. So I'm going to try and do that with a marker. Okay, just a normal whiteboard marker. So I'm just drawing out the places that didn't uh, print well. Sometimes it works, sometimes it does not. Okay. See, with this marker patching, you realize that for traces that are very thin, you can't patch with a marker. Okay, so the point where you are ironing, that's where you have to make sure you get everything right, because the moment that is done, you may have to clean it and repeat the whole process again, and that's not something interesting. That's why I don't want to do that again. So, but the outcome we can actually work with, just that you have to do some patches when we are fixing the circuit. So I'm trying to do with those that I can fix with the marker, and the rest I will fix them using the soldering iron and some lead. Okay. Okay, so as you can see, I'm patching the places that got broken. For the very thin lines, I can't do anything about them, so I will just have to fix them using the soldering iron. Usually, when you are working on a large board, yeah, these things are bound to happen because you cannot evenly iron the entire surface. Okay, if the board is smaller, you end up with mostly you get very nice looking boards. Okay, but when the board is bigger, say as you are ironing one side, the other side is cooling. Okay, so you have that kind of uneven temperature, whatever you call it. So yeah, the rest. Okay, so let me patch this place. Okay, so I think this side is good. Turn it and then see what I can fix at the back. This place is mostly good because we don't have much of the we don't have much of the traces here. Okay, they are all at the back side. They are all at the back side. So yeah, this place should is actually looking better than the other side. Okay, so actually the patches that I've been doing so far are all the ground, which is quite okay. So every part that is not covered by the toner will be eaten up by the solution that we are going to use for etching. Okay, so the black thing that you see, the black covering, is going to be our circuit after etching. That will be the copper that will be used as our circuit. The rest will all be cleared off. Okay, so I think we are good. We can work with this. And anyway, I don't intend to do a new one. Okay. Now, another thing that we should be worrying about is the alignment of this board. Okay. But as it stands, we can't know whether the board is properly aligned or not unless we finish etching and probably drill it. That is the point where we will know. Because when you start drilling and the faces are not aligned, then you'll be missing your holes. Okay, so yeah. All right, so the board is good to go. Now, the next thing is to prepare the etchant, which is the solution that we are going to use to etch the board. Is that okay? There are many things like that, many chemicals that you can use for the process. I think one of the most used is ferric chloride, right? But I prefer something called hypochlorite, hypochlorite, which is actually a solution of hydrogen chloride or hydrochloric acid and hydrogen peroxide. Okay, HCl plus H2O2. HCl plus H2O2. That is the solution that we're going to use. Now, word of caution, ACl is acidic, so you don't want to be playing with it, okay? So what I usually do is I take one part of the HCl and add it to two parts of the hydrochloric acid, okay? Yeah, that is the etchant, and this one is faster compared to the ferric chloride, and it also gives you a very neat work compared to the ferric chloride. Okay, so I'm going to do the mixture right now, and then we proceed to etching. Now, when you open the ACL, you get some smell that can choke. It can choke you. So you make sure you are doing this at a very airy place. Is that okay? Don't do this in a closed door or something like that. Let me have the chemicals. Okay, so this bottle contains my HCl. You can see that it is properly tight. Okay, it contains my HCl. It's actually a wash bottle. Please don't do these things without supervision. Okay, if you don't know what you are doing, don't work with hydrochloric acid without supervision. Okay, and don't do it without gloves. However, I'm doing it without gloves. All right, now simple chemistry uh, rule that I remember: pour acid onto base, not base onto acid. If my chemistry teacher is looking at me, probably she's proud. Okay, so this is the hydrogen peroxide. Okay, this is the hydrogen peroxide. You can buy this from pharmacies. Okay, so pouring some part of this hydrogen peroxide into the bowl. Okay, I poured about half of it. It's actually too much. Then for this one, I'm going to do a very non-scientific. Uh, I'm going to do a non-scientific measurement. Okay, so squeeze this, pour some, not so much. Okay, so just so mostly I take one part of this to like two parts or three parts of the peroxide. Okay, all right. Now take note. This is HCl. You don't want to joke with. Okay, all right. So it's still colorless. The solution that we have is still colorless. Okay, that's why you can't even see. Now, the moment I put the copper board into it, it's going to this thing. The bowl is too small. The bowl is too small for this work. Right. So the etching process. Unfortunately, the previous container I was using couldn't house the board, so I have changed it. So the etching process has begun, and at this point, you need protective nose mask and all those stuff. Okay, you have to be very careful. Uh, I can smell hydrogen gas coming out. Now, if you are interested, you can find out about the chemical reaction going on. But eventually, the solution will turn greenish. Okay, this is because of the formation of copper chloride. Okay, that is why we are going to you are seeing the solution turn green. All right, so you just have to keep stirring for the and this particular reaction solution doesn't take long like the ferric chloride. Okay, so we should be done in a very few minutes. Okay, it looks like the solution is too small, so adding some peroxide. Okay, so and it also looked like the hydrogen chloride was so much, so you could see it bubbling. Okay, so I diluted it with some of the peroxide. Well, this has actually kept too long. some few drops. All right, I can see the copper starts wearing off. So the reaction should be completed very soon. I think it has taken this long because I didn't pay attention to the concentrations. Okay, so yeah, because mostly it doesn't even take this long. You can see that the board is changing color. Okay, yeah, the reaction is ongoing. Okay, so you can see that gradually the board has changed color. Okay, it's no more brownish as it used to be. And now it is taking the color, the dominant color is the color of the substrate that was used for the copper board. Okay, but then the edges are not properly etched, so I'm still going to allow it to uh, do some time in the solution. And the interesting thing is that the back side of the copper, the other side of the copper, also gets perfectly edged. Please take notes. We are dealing with acid, and so you should be careful when you are working with this. Good metal plastic. You make sure nothing metallic comes into contact with this solution, and you also make sure that it doesn't touch your skin. Okay, so always have a bowl of water around. Okay, so that in case of emergency, you can use it immediately. Okay, yeah. The solution can be very concentrated. In fact, this is so concentrated, so even if I put a paper in, it can take some deformation. Okay, so going to turn this. As you can see, the back side too is properly etched. Okay, yeah, the back side is properly etched. So at this point, you have to take it out of the solution and put it in water. Okay. Mm-hmm. Can we get more water? Wash this fast. Okay, so you put it in water, wash it. Okay, make sure you wash it thoroughly. And in fact, you should dip it into water. Okay, a lot of it. Okay, like I said, make sure you do this, especially if you are a student. Make sure you do this under supervision. Okay, and always wear gloves. Always put on what? Gloves. Okay, so you see, by using the photo paper, there was no need to soak the paper to remove, we could just peel it off to leave the design. Okay, so everything you see in here, the black things you see, they are actually, that is actually our circuit. Okay, that's actually our circuit. Now the next thing we're going to do is to clean this black toner. Okay, and when I start wiping it, you should see the copper coming out. So the copper that was taken away were those that were not covered. Okay, so this is the process known as subtractive, whatever. The PCB guys have some name for it. Okay, it's a subtractive process. You have a whole copper layer and you take the unwanted part out. Okay, all right. Take this away. Take the wood away. Can we? Let me tissue. Okay, so at this point, I have to clean this. Okay, I could use acetone or thinner. Acetone is the best, but I don't have some available, so I'm going to use thinner to do that. And you can use this with any soft cloth or even tissue paper, right? So pour some, please cover the acetone. Pour some. Bring this, the other book. Bring the other book. Don't put it in it. Don't throw it away. Don't throw the water away. Not the water. Okay, so you can see the copper coming out. Okay. Hurry up, hurry up. Clean the process. Please, when you are doing this, make sure you are wearing gloves. All right. Yeah. Fast. You still need something else to clean. This one is dirty now. Put this in the water and see if it. All right, so you can see that our board is neatly etched. Okay, and this particular process doesn't, it's not dirty like the ferric chloride, but of course you have to be very careful when you are working with the hydrogen peroxide. Okay, yeah, in case you would want to repeat this process and you are not sure, you can send me a mail or get in touch and I'll guide you through. I'll try and follow this up with the right combinations of the chemicals so that those who want to be using this process can use. Okay, so our board is ready, right? Our board is ready. Take this away. All right, so Nicely done. Okay, it was challenging, but we still put it out. Okay, double-sided board. Now I can't really confirm whether the board was properly aligned or not unless we drill. So the next thing we're going to do is drill the holes. Now, because of the fact that you may miss the alignment, when you are drilling, what I intend to do is if I drill at where the traces are, okay, the holes, the side of the hole where there is a trace, that's usually where I drill so that um, I get that particular point right. Okay, so I'm going to drill this board. I have this drill with me, and it has a 1 mm bit. Okay, so I'm quickly going to drill the board. I'm not going to record that process. So after that, I will continue with what's next. All right, so I'm done drilling the board. Okay, and I don't have a grinder here to shapen it very well, but then I think it's all good. Now, the last thing to be done is you have to clean it again with a fine wire gauze. Okay, and then the board needs to be protected. Okay, if you leave it like this, in no time the surface will start corroding, and you wouldn't like your board. Okay, because copper is very reactive to atmospheric oxygen and water vapor or moisture. So in order to protect this, I'm going to spray it with this spray. Okay, we call it, it's an acrylic spray. And I used to use, I remember some days ago, I used to spray lacquer on it, right? But the lacquer, when you're about to solder, you have to scrape off the, what do you call it? The point, the soldering point, right? But with this acrylic spray, okay, with this acrylic spray, you can actually solder through it, okay, and yeah, so you don't mind spraying on the entire surface of the board. And one beautiful thing about this is that it leaves the surface of the board shining, okay, it gives it that glossy feeling, okay. So that is the last thing that I'm going to do. I'm going to shine this, polish it once again, and then spray this acrylic spray on it, okay, and this would protect the surface against corrosion. And once it dries, I can touch it, hold it, work on it, and everything will be good. All right, so for the last part of the session, I'm not going to record. Okay, now things that I need you to understand, that I've been doing this for years, I still don't get it perfectly right. Okay, so it is okay if your first shot doesn't come out neat. Is that okay? It is okay. Okay, so it takes some amount of practice to really get this thing right. Is that okay? And when I get back to my lab, I'll try and see if I could do something very detailed. Okay, I have to come up with this because of the program I'm doing. So I'll see if I can find time to do something very detailed and maybe find out what really, what parameters you really have to pay attention to in order to get this thing working perfectly. Okay. All right. So, um, if you need help with PCB, if you want to develop a proper PCB, industrial grade, yes, you can contact me for that. And if you also need help in the chemical mixing of the chemicals, too, you could probably send me an email or something. Okay. But no matter what you do, make sure that you are doing things right, especially when you are going to, if you are going to use the acid, the ACl, and the hydrogen peroxide, then be very careful. Put on gloves, put on uh, goggles, any form of protective thing, okay? Especially if it is your first time, okay, so that you don't get any accidents or that sort, okay? All right, it has been a very interesting ride with you today. I am Professor. Once again, don't forget to share, like, and subscribe to this channel. There is more from where this came from. Right. Thank you. See you in class in the evening.